Bismillahirrahmanirrahim. Dear students, today we are going to start chapter 5 of simple integration. But before going to start the questions of the exercise, we will give an overview of the formulas that we will use in the integration. So the first formula that we are going to use is integral dx is equal to x plus c. Then the second formula that we will use is commonly known as power rule. X raised to power n dx is equal to x n plus 1 over n plus 1 plus c, where c is the integral constant. In every question or every integral function, we have to put the constant sign, which is plus c, because we are using the indefinite integrals, and in indefinite integrals we will always reserve a position for the constant that will come afterwards. Integral cos kx dx is equal to sin kx over k, because the derivative in differentiation we multiply the angle. Here in integration we divide with the angle, plus c integral sin kx dx is equal to minus cos kx over k plus c. Then fifth, we can say that is secant square kx dx is equal to tangent kx over k plus c. Then sixth one is, we can say that integral cosecant square kx dx is equal to minus cot kx over k plus c. 7. Secant kx tangent kx dx is equal to secant kx plus c divided by k. 8th one is cosecant kx cot kx dx is equal to minus cosecant kx over k plus c. Dear students, these are the formulas, few formulas. Further formulas will be discussed as we proceed with the complex type of questions. So now we proceed for the questions of exercise. Now let's start with some questions. So question number 1, integral x raised to power 4 dx. Now here we will apply the power rule. X raised to power 4 plus 1 whole divided by 4 plus 1. Since the integration is complete, so we put the sign plus c. So just simplification will be required, and it is the answer. It's a one simple question. Now question number 2, integral x cube under root x dx. Now first of all, we will change the power of the square root as 1 by 2 and then add cube and x raised to power 1 by 2 dx, which will be integral x raised to power 3 plus 1 by 2 dx, which is x raised to power 6 plus 1 over 2 dx, and finally x raised to power 7 by 2, which is ready for the integration. So x raised to power 7 by 2 plus 1, 7 by 2 plus 1, integration here completes, and we put the sign plus c. So x 7 plus 2, we have taken the LCM of the power. Similarly, with the denominator, this is x raised to power 9 by 2 and 9 by 2 plus c, or further simplification gives us 2 by 9 x raised to power 9 by 2 plus c. Question number 3, integral x raised to power 3 by 2 dx. So x raised to power, we have to integrate, so x2 plus 1, so 3 by 2 plus 1 plus c gives us x raised to power 5 by 2, 5 by 2 plus c, and 2 by 5, x raised to power 5 by 2 plus c is the answer. Now question 4, integral x 2 by 3 minus 4 x raised to power minus 1 by 5 plus 4 dx. X raised to power 2 by 3 dx minus 4 integral x raised to power minus 1 by 4, sorry, it's 1 by 5 plus 4 integral dx. X raised to power 2 by 3 plus 1 over 2 by 3 plus 1 minus 4 x raised to power minus 1 by 5 plus 1 over minus 1 by 5 plus 1 plus 4 x plus c. X raised to power 5 by 3, 5 by 3 minus 4x, 4 by 5 whole divided by 4 by 5 plus 4x plus c, and finally 3 over 5 x raised to power 5 by 3 minus 4 into 5 by 4 x raised to power 4 by 5 plus 4x plus c. This 4 cancels, so final answer is 355 x 5 by 3 minus 5x 4 by 5 plus 4x plus c. Now question number 5, integral x 1 plus x cube dx. Here first of all we will simplify by multiplying x inside, x raised to power 4 dx and integral x dx plus integral x raised to power 4 dx, x 1 plus 1 over 1 plus 1 plus x raised to power 4 plus 1 over 4 plus 1, and finally plus c. Now we simplify it by 2 plus x raised to power 5 by 5 plus c. Question number 6. Integral x raised to power 5 plus 2x square minus 1 over x raised to power 4 dx. Now first of all we will write the numerator and denominator separately, that is we are dividing each term. Plus 2x square over x4 minus 1 over x4 dx. Integral x plus 2 integral 1 over x square dx, and here there should be dx minus integral dx over x raised to power 4. So x 1 plus 1 over 1 plus 1 plus 2 integral x raised to power minus 2 dx minus integral x raised to power minus 4 dx. X square by 2 plus 2 x raised to power minus 2 plus 1 over minus 2 plus 1 minus x raised to power minus 4 plus 1 and minus 4 plus 1 plus c. X square over 2 plus 2 x raised to power minus 1 minus 1 minus x raised to power minus 3 over minus 3 plus c. X square over 2 minus 2 over x plus 1 over 3 x raised to power 3 plus 1. This is your integral for the given question. Now question number 7. Integral 4 secant square x plus cosecant x cot x dx. So integral 4 secant square x dx plus integral cosecant x cot x dx. So taking 4 outside the integral, we have secant square x dx plus integral cosecant x cot x dx for tangent x plus minus cosecant x plus c. So 4 tangent x minus cosecant x plus c. Actually these questions are related with the formulas that we have so far studied. So no complicated question has been used. Now question number 8. Integral secant x plus tangent x dx. Integral secant square x dx plus integral secant x tangent x dx. Actually we have multiplied this secant x with this term and with this term. So the integral of secant square x we know is tangent x plus, then the integral of secant x tangent x is secant x plus. So simple question. Now question number 9. Integral d by cosecant y. So simply we have to first of all convert it equivalent, which is sin y dy, and the integral of sin y is minus cos y plus. Now question number 10, integral sin x over cos square x dx. Now here we will split cos square x as cos x into cos x. Sin x over cos x multiplied 1 over cos x dx. So we go there, tangent x and secant x dx, and the integral of tangent x secant x is secant x plus c. Now in question number 11, integral phi plus 2 divided by sin square phi dy. So again applying the sum rule and separating each function, phi d phi plus 2 integral 1 over sin square phi d phi. Now here 1 plus 1 applying power rule plus 2 integral sin square is equal of cosecant square phi and d phi, and the angle is the phi, and we have its integral easily available, that is phi square over 2 plus 2 minus cot phi plus c. So phi square over 2 minus 2 cot phi plus c, answer. Now in this question number 12, we have a question in which we don't have any direct integral available, so we have to make some replacement of the corresponding value of the trigonometric function. So here, this one, we have a formula sine 2 theta is equal to 2 sine theta cos theta. So we will replace this value by sine 2 theta is equal to 2 sine theta cos theta. Integral 2 sine x cos x over cos x dx. Now this is cancelled, 2 is constant taken outside, sin x dx, and we have the integral of sin x as minus cos x plus c, so minus 2 cos x plus c. Now in this question, we will rationalize the denominator as 1 over 1 plus sin x multiplied by 1 minus sin x over 1 minus sin x. So 1 minus sin x whole divided by 1 minus sin square x dx. So integral 1 minus sin x over cos square x dx. So integral 1 over cos square x dx minus integral sin x cos square x dx, integral secant square x dx minus integral sin x over cos x multiplied by 1 over cos x dx. So the integral of secant square x is tangent x minus integral tangent x secant x dx, and finally tangent x minus secant x plus c is the answer. Now in this question, integral 1 over 1 plus cos 2x dx. Here we will use double angle formula for cos 2x. So integral 1 over 1 plus 2 cos square x minus 1 and dx. Now this one and this minus 1 is cancelled, so 1 over 2 cos square x dx, 1 over 2 integral 1 over cos square x dx, 1 over 2 integral secant square x dx, and finally 1 over 2 tangent x plus c. Now these are the questions that we have used for the simple integration from the formulas that we have studied now, and these questions are from exercise 5.2 of the book that we are studying. Okay.